All right, welcome to my midnight sessions, right? You hear that? That is the wind the Santa Anas have picked up in Southern California, and as a result of that, we are seeing at possible power outages all the way from now, Thursday night, all the way to Saturday. So somewhere in the weekend, right? So we might lose our power, and as a result of that, of course, I am working on my batteries, right? These are the scooter batteries that we got, a bunch of them. Here we go. There's just pallets and pallets of these guys. And I have taken them apart. I've taken the casing off and then taken the rubberized covering off of this. And then what I did here was connected just a little XT60 connector, right? And the reason I'm doing this because I want to test these at full load. I want to test a bunch of things, right? Here, for example, this is a shrink tube, right? PVC, right? This is commonly used for batteries. So I was testing to see if we had the right size, and we did. So of course, here's where we're at with this. We have a bunch of them. We haven't figured out how to wake up the BMS, right? And so what I did here was just bypass it. So I bypassed it. But the cool thing about these battery packs is that they have access to all of the balance leads, right? So these are the contacts where you need to put if you wanted to put an external BMS. And so that's what I'm going to do on this pack here. This is the initial phase one, I called it, right? We first figure out how to use them with an external BMS. And then after that, then we figure out how to use the internal BMS. And then at that point, we don't even have to take these things apart. We'll use them as is. But for right now, I want to test them. I want to see that. Here's the connector. I've ordered some of these connectors because all of these pins are in here also. And so if we just find the right connector, we'll be able to connect that in there. And then we have what it's going to go into the external BMS. And then that's going to be pretty awesome. Of course, there are some challenges. They have they're full of that rubberized compound that they're using. So we're going to see if we're able to cut this stuff out or just push it in there and hopefully make good connections. It might work, it might not work. We might have to solder stuff. And for example, in something like this, if you wanted to make a power wall, put it in one of these boxes, right? What you would have to end up doing is connect it like this, and then basically parallel every group, right? So you would have to go, this is most negative. No, this is, most negative, most positive. This is most positive. So this is already all paralleled over here. So what you have to do is you have to parallel this to this, to this, to this, to this, to this, right? All the way up. And then the same thing with this one. You bridge all of those together, and then you bridge all these together and all these, right? All the way, all 10, 11 pins. And then after that becomes one battery pack, right? 10S. This is 4P right now. So 4, 8, each one has 4 cells. So then you multiply that by the number of packs that you have. So that's what I'm doing here. I have connected. So another one of the things that I'm using, it's going to be this. This is like the high power power strip that we make, right? We have layered these in 2 PCB boards, and we should be able to handle up to like 150 amps before this getting too hot. But of course, this is limited by this connector here that I've chosen to use. And this is only rated at 120 amps. And this has 6 gauge. Well, actually, I'm using 4 gauge wire here. So we're gonna do these tests here and see what kind of temperatures we see this at full load. I have this connected in here. And then it's going through our little meter. By the way, this is the meter that I started carrying, that I ordered from China and finally have it in stock. This one's rated at 500 amps, 500 volts, 500 amps. So this one, you basically will be able to use it pretty much with any battery system that you want, all the way to 500 amps, 500 volts, 500 amps. That's quite a bit of power. And this is the wireless version. So this little cable here, it's powering this unit, but you don't have to power it from here. You can power this from any other 5-volt USB source. And this has like a little radio in here, and then there's the other radio. And so you can put this inside your house and then put this inside, or monitor this like battery system that's maybe outside, right? And so that's the cool thing about these. Then what I have going is here, after going the meter, I've going to these 4. These are grid tie inverters, 1,000 watts each. So we're going to be able to pull 4,000 watts, 4 kilowatt. All right, so this is big stuff. This will run the average home, right? As long as you don't have, even my AC unit pulls about 4 kilowatts, right? So this could do that, right? Maybe like, I don't know, like 5 kilowatt, maybe you'll be able to run an entire home, including your AC. Maybe a modern home with a very efficient AC unit, this will run 4 kilowatt. It's big power. And so to think that we're going to use these scooter batteries to run that, it's pretty crazy. But we are. All you have to do is parallel enough of these. There's 16 of them here, right? 8 in series, and these are all being paralleled, and all through these PCB board based power strips, right? So let's connect this whole thing and then check the temperatures. See where we get, see what starts melting, see where we get at, right? So let's start this test. Let's connect it. I'm gonna connect these and then we'll be back. Okay, it's a good idea to go sequential, right? Don't go all crazy the first time you're gonna do something like this. So what I've done here is connected these two. And so these are about to go live here, 62 amps. So these cables are going through here, through these 4-gauge wires, and then they're going out here. I was gonna put it in the center here, but whatever, we'll see how they do. So here we go, 60 amps. The packs are holding their voltage. These are not 100% charged because I've been charging them all day. This is quite a big battery here. What is this? Like 14? I forget. Each one is like about 460 watt hours, and there's 16 of them. There's quite a bit, right? Like, yeah, almost like 7 kilowatt hours or something like that. So it's a big battery pack. But here we go, 64 amps. Let's put on the other two here. All right, here we go. Now we've plugged the third one. Voltage is holding at 36. Ooh, there we go, 97 amps. Oh geez, when I plug this is gonna go full 120, maybe plus. Okay, let's plug in the third one, the fourth one actually, and then I'm gonna grab my thermal camera. Ooh, what is that one doing? 82, yeah, okay. Here we go. So that's about to go. This is about to start, hopefully. Oh, that's taking a while to get going. Huh. What's going on with that one? It's not starting. Oh, there we go. It's starting. 130 amps. 130 amps. Let's look at the thermal camera. Let's see what we're doing. Woo! Look at that. That one. I mean, this is nothing, right? 80 degrees Fahrenheit. I should have changed this to Celsius, but I didn't. And so here we go. Whoa! Here we go. Oh, look at that pack. So that pack, there's something on it. That pack for some reason is warmer than all. Now this is not hot. All these packs are really cold. right now, right? There's about 72 degrees Fahrenheit. This is 81. Well, so almost 10 degrees above ambient here. And this is, I was charging it. I just finished charging it. So this is a byproduct of the charging. Let's see if this remains that hot or if all the other ones join. But that is the closest one to this cable where the power is coming all out, right? So maybe that is the reason why. But then this one would be the same thing. So maybe this is just a pack that is compromised, that for some reason is getting hotter than all the other ones. So this is the cool thing about this, these thermal cameras. You'll be able to see any problems that are arising from this. So 99 degrees Fahrenheit, right at that point right there. That's 100 degrees. That is the point where all of the energy is conversing, right? It converges there, and then it leaves through the the main connector there, the 4-gauge wire, and then through this connector here. So this connector is rated at 120 amps, and we're pushing about 130 amps right now. Let's see how well it handles that. 85 degree Fahrenheit. This is all, by the way, this is just warm. This is nothing's overheating anywhere. This wire is rated at 200 degrees, like Celsius, which is, I don't know how much that in Fahrenheit, but we're nowhere near there. This is all, if we touch it, here's my hand, right, at 82. This is just, just a few degrees above that. This is just warm to the touch kind of thing. So here we go. Let's step back and look at it from afar. There we go. Look at that. There we go. Let's go look. Go see how we're doing. Yep. 130 amps. That's 4,600 watts. Look at that. Out of the battery. The battery's holding at 35.6 volts. How long have we had this test going? Did we check here? Damn, this thing doesn't have a timer, does it? Well, it's been a few minutes. I guess we won't be able to. All right, something you have to keep in mind when we're doing a test like this is that to dump all this power from these batteries into your AC wiring, you have to do it at least in 2 circuits, right? I have 2 different circuits. I have one circuit going for these 2, right? Because these are basically pushing to 2,000 watts. And that is maxing out that circuit, right? About 20 amps or something. And then this one is going to a different one. So yeah, you have to make sure that you connect those right. So I mean, I could potentially, if I keep this test going long enough, I'm probably going to trip those breakers, right? Because they're pushing, those are rated around 1,500 watts, right? What's 20 times 120? All right, here we go. Now I've changed the settings to show Celsius, right? And let's see how that pack is doing compared to all the other ones. There we go. Stand back because this camera is 26 degrees Celsius. See, I think everything's evening out, right? So all the other packs, I think, are warming up, and this one is still staying a few degrees above that. Everything else seems to be around 21, 22. That one's at 26. And then here we go, 38 on that cable. Let's go check out the hottest place in that the power strip, right? So it's right about there. So it's about 53 Celsius right there. 54, 55. there we go. Now that's still, pretty much like a hot day in Australia. It's hot, but it's nothing to worry about. These PCBs are rated really high, somewhere around like 90 degrees Celsius or 150. I know I read it like the PCB material is like around 150 degrees Celsius. But of course, everything else, those connectors are probably doesn't go that high. I'd say we don't have to worry about this until we reach like 90, maybe 100 degrees. Probably 100 degrees, that's where I would stop this stuff in here, so make sure nothing's melting. But that's what these tests are for, just to see where stuff starts melting and how this setup would run, on a continuous mode here. So, maybe like a half hour of running this, or maybe until the batteries are depleted enough where the inverters are no longer able to, convert that, or we trip a breaker, something. Let's see what goes first, right? That's the purpose of these tests right here. So there we go. All right, so I wanted to mention something else about these high power DC power strips, right? Or distribution blocks. Think about them as that. You basically, all the batteries dump their energy in there and then you remove it, right? So like this is, warm to the touch here at 130 amps, right? So, like if you wanted to run this in a continuous, like let's say 130 amps on a continuous mode, then also in order to alleviate this heat that is being generated in these wires, there's a few things that you can do. Like you can use thicker wire, but then it becomes really like hard to put that into this little PCB here, right? So what you could also do then is put more points where you remove the power, right? So this is 2 of these PCBs, or 2.5, 2 and 3/4. We have to cut it in there, and then all these 6 packs right here are dumping their power through this connector in here, and then it's going out, right? So it's not exactly right on the center of the pack, as you can see here, right? So there's one side that has more packs than the other, but you could connect on something else over here. In fact, here's another point on this PCB that you could put another one of these big beefy connectors, right? And so if you have 2 and then you split those 2 connections per, one into 2, one per every 2 of these inverters, then you would eliminate all of these heat, right? Or you would run at much lower temperatures at a continuous mode. So that's just, another strategy that you can do to use these. So these are pretty versatile. You could do a bunch of things with these. You can push them quite a bit, and that's what I'm testing here and showing you guys just how much you can push that. It's 130 amps. Sounds like a ton of power that you should not be able to do through a PCB, but you can. These are 2 ounce copper, and there's 4 layers of copper in there, and we try to use beefy, like a lot of solder into those connectors and all that stuff. So we designed this stuff and then we put it to the test, and then that's how you come to the ratings, right? You design something, you build it, and then you push it to its limits, and then you see where it starts breaking, where it starts melting, and that's how you do it. All right, so 21 minutes into the test, the voltage is dropping, right? So 34 volts right now. So that means the amperage is going up 137 amps, which means that this temperature is going to be higher. Yeah, look at that. 68, 69. There you go. Let's see. What does it feel to the touch here? Yeah, I would call that hot now. You can put your hands in there for a little bit, but then after like a few seconds, and it's uncomfortable. So yeah, 70 degrees Celsius. That's where it's at, right? So yeah, let's see how that runs. That might be the maximum here that will set these. And look at that. That connector's it's working. It's rated at 120 amps. We're running above the rating here, 130, almost 137 right now. And look at that. Those cables are 50 degrees right in there. What happens over here? They get colder over here as they go back here. Huh, that's weird, huh? That connection right there seems like it's the hottest, 49. These ones, maybe that's loose. That's a loose connection right there. It has to be. Maybe that's the reason why. Let's see, can we fix that? Oh, yeah, that's loose. What? This one is loose too. No way. Look at that. We just caught a loose connection. Either I forgot to tighten that, or it loosened up maybe with the heat. I don't know. I probably just forgot to tighten that. We will check on that and see that go down. Look at that. It's already going down. 40. It's already coming out 10 degrees. Wow. So here we go. Let's check back here. 60 degrees. 67. $64. Let's check on the 138 amps. There we go. 138 amps. And let's look at the batteries, how they're doing. The AC side of things. Yeah, those are not hot at all. So here we go. We get to see the whole thing, and right there, right where all the power leaves, that's the hottest place. So yeah, I'd say above 4 kilowatt, you would want to use at least a couple of points in those power strips there. All right, so 40 minutes in, and the battery's voltage is low, 28, right? So that's it. This is ramping down, right, because of the voltage. What are the voltage ranges of this? According to this, it will go from 22 to 65, so around 22 volts it'll stop, and we're about, well, we're 6 volts away from that. These, below 30, it's not good. Like you would want to set this guy right here to put a relay, or somehow let these guys know to shut down, right? So that it doesn't take your batteries this low. This is really low now, 27 volts, 27.8, right? And so then these guys then start struggling. So it's a well-matched system. I wish it would stop here. I think you can set these to stop at a certain voltage, and so I would set it to 30 volts, right? I think this tested great. Nothing broke. Nothing got way too hot. This got all the way to 70 degrees Celsius, which is about 150 degrees Fahrenheit or something like that. That sounds like a lot. I know it sounds like a lot, but all this stuff is rated for way more than that. Of course, there's efficiency being lost there when you're creating heat in conductors and in wires and stuff, right? So the less heat that you can create at your nominal or at your continuous load, then the better it is, and the longer that your equipment will run, right? So So you have to decide just how much, you know, you want to do and design and put, and how many connectors, right? And how much you want to size your cable and stuff. But this is all high temperature, you know, cable, right? This is rated at 200 amps. The boards can handle somewhere around 150 amps C, right, Celsius. So this is all safe. This even at this level of heat and stuff, it'll be fine. There we go. It's tapering down now, 100 amps. But look at these, 25. So this is really low, but it's nothing dangerous, because if you know, the 18650s are usually rated, right? The capacity is rated all the way down to 2.5 volts, right? So around 25 volts. That's what the manufacturer uses to test the capacity of these cells, right? So, of course, if you do this on a normal daily basis, then your cells are not going to last very long, because that's where all the damage happens. It's at the very extremes, at, you know, the very low voltages and the very high voltages. So if you want your batteries to last a very long time, you stay away from these edges, right? From the 25 volts and the 42 volts, right? So you stay in between 30 to 41, 30 to 40 volts, right? 10 volts in there, these things will last you forever. And so that's what you want to do. But because we're doing a test here, we're pushing this stuff to the limit. There we go. See, this is all ramping down. All of these inverters are ramping down. 170 watts, 330 watts, 300 watts. This one, this one's taking a little bit longer, but it's starting to ramp down, right? There we go. So now we're down to 60 amps, total, and it's right before we're getting to the very critical 25 volt, the lowest maximum that you want to take these cells here. Oh, what's going on here? This one's starting again. It's trying to start, maybe. Remember, these are solar. I mean, they're designed for batteries also, but they I haven't gone in there and checked to see if there's a setting where you can choose to tell it that you're using a battery instead of a solar panels, right? Oh, there we go. See, we went past that, and it's still at 67. Yeah, so, okay, so this one turned down to 23 watts, but this one is staying at 300. This one's the one that's going up. This is the one that's screwing with that, keeping it at 50 amps. So I think there's a little bit of leeway here. Going through the menus, you should be able to set it so it doesn't go as far as that. And if it doesn't, then this meter here has the ability to set a contactor, an external relay that will step in, and you can set the voltage, the low voltage cutoff, so that it disconnects, and then it saves your battery from going this low. So there we go. These are all, now they're chirping that high frequency tone here, and that's it. They're ramping down. Because remember, the low is that they can work with is 22 volts. So this is a 23 volts. Yep, that's it. Then they're gonna sit there and idle, right? And then at this point now, you should have your charger ready, so that, if it's solar, then use the sun to charge these. If not, if it's from the AC, from the grid, then you charge these. But all right, I'd say this is a pretty successful test. We tested this stuff. Nothing got too hot. This is the minimum, I say, that you would want to run this much power, 4 kilowatt, right? And so when I put this into a box, if I leave it like this, then it's fine. But if I double this and put another set of 16 cells, then it's much better. Then these cells are going to be happy. They're not going to have a stressful life, and they're going to last forever, right? So there you go. This is just a test. These, by the way, are on sale at Jack 35, and I'm currently running a Black Friday sale. And so if you want to get your hands on a lot of these at a very good price, then, just head over to jack35.com, and then all this other stuff too, like all this little stuff to connect and the thing, all this stuff, you can find it there, right? So thank you for watching this video. We'll see you guys on the next one. And the next one, I'm going to show you how to connect the BMS, and then how to put them in a box, and how to put the box in the wall, and then how to connect that into the building. And so stay tuned for those videos coming up in the future. We'll see you guys in the next one. Bye.